Hello everyone, my name is Farzana Sultana Samia. I'm a PhD student in Computer Science Department at Iowa State University. Today I'm going to present one paper from EMNLP which is published in the year 2023. The paper name is KICGPT, Large Language Model with Knowledge in Context for Knowledge Graph Completion. The authors are Yanbin Wei, Qiushi Huang, Zhang, and James Kwok. Before diving into the details, I will going to tell about the outline, what I will going to cover in this presentation. First of all, I will tell about the problem which is addressed by this research work. Then I will tell about the contribution which is made by this research work, and then I will tell about some prior work of this research work. Then I will explain the methodology of KICGPT in detail, followed by a discussion of experiments conducted and their results. After that, the conclusion. The knowledge graph. Knowledge graph basically constructed by triples. Triples is basically formed by head entity, relation, and tail entity. You can see in this picture, like every circular nodes or entity is connected with their corresponding nodes or entity based on their relationship. For example, Mona Lisa is in the middle of this picture is connected by the famous painter Da Vinci with their relationship painted. This is kind of a real-world representation of knowledge. Knowledge graph basically plays a crucial role in recent times, and it is basically used in many downstream tasks as well. For example, recommendation system, question answering, knowledge discovery. However, it has been used in many tasks. Knowledge graph faces one problem, which is incomplete triples. Often, knowledge graph faces the problems of the missing entity. In order to address this issue, knowledge graph completion aims to predict the missing entity. This task is also known as link prediction task. You can see in this figure, like every green arrow is presented in the knowledge, but the red arrow is missing. From Palito to Italy, the relation is missing. So the knowledge graph completion aims to predict this accurate relation of these two nodes. So this is the main task of knowledge graph completion. There are two approaches to solve these missing entity problems. One is triple based, another one is text based. Triple based method is a traditional method to solve this problem. This method is basically used the structured form of knowledge. For example, you can see the Paris is capital of France. Here, Paris is a head entity, is capital of its relation. France is a tail entity. This type of structured knowledge is used in this method. For that reason, this method faces one major issue, which is less frequent relation, long tail entities due to the limited structured information and imbalanced entity distribution. For example, a well-known actor have many relation to various movies, awards, and other actors, whereas a lesser known actor might only have one or two relation. To address this long tail or less frequent relation problem, researchers invented text-based method to alleviate this issue. They can mitigate this issue by incorporating description with their corresponding nodes or entities in order to availability of information, because it requires training and fine-tuning. This is kind of a resource intensive and requires task-specific fine-tuning for each downstream task. You can see the example, Paris is the capital of France. This is kind of a natural sentence or language. This will help method to understand more better contextually, but it has an issue which is computational cost. To address these issues, this research work invented one novel and a cost-effective framework for knowledge graph completion task. They basically first combines the large language model with traditional triple-based method. Another key innovation of this research work is knowledge prompt. Here, they basically applied in-context learning strategy for knowledge graph completion tasks. They basically helps guide the LLM by providing relevant information, allowing the model to understand the context better and make accurate prediction without the need for additional training or fine-tuning. They addresses the limitation of long-tail entities for both triple-based and text-based method. Now moving on to the related work, the triple-based method. They basically represent the entities and relationships as low-dimensional embedding vector in a continuous embedding space. And there are some well-known research method or research work, including Trans-E. Trans-E basically use translation-based embedding, and Rascal and Dismal is a semantic matching-based models. These models basically rely on the structured format of information, and this type of information faces one problem, which is a long tail problem. To address these long tail issues, researcher invented the text-based method. There's basically they included or incorporate description from other sources, and this is basically helps to reduce the unavailability of information. For example, DKRL research work basically applied the convolutional neural network in order to produce entity embeddings from textual description. Some recent work like KICGPT, Kepler, pretrain also use pre-trained language model to encode the text description. LMK used the PLM to obtain entity and relation embeddings in the same space as word tokens. Researcher also explores what large language models has the potentiality for knowledge graph completion tasks. For example, StructGPT. This model is basically improve the zero-shot reasoning ability of large language model on structured data. This StructGPT is basically designed to solve the problem of knowledge graph question answering task. And another related work is in context learning for large language model. This research work is done by Brown et al. In the year 2020. They basically provide explicit instruction and demonstration to guide the model's behavior. Now moving on to the methodology of this research work, starting with problem setting. Knowledge graph is a set of triples. This represent like G is equal to H, R, T. H is belongs to head entity, T is belongs to tail entity, R is belongs to relation. The main goal is to predict the missing entity, which is also known as link prediction task, and the given incomplete triple can either be missing tail entity or head entity as query. This is the main framework of this research work. There are main two tasks, which is KGC retriever task, another one is re-ranker task. In KGC retriever task, it is basically take input as a missing query triplet. You can see in this missing query triplet, like Milan is a head entity, man to travel is a relation, and the tail entity is missing. This KGC retriever take this missing triple as the input and give the potential candidate list. This KGC retriever basically scores each and every entity based on the similarity of query, and then organize this list as a descending order, and the highest priority score will be at the top candidate, and this R retriever candidate list will pass to the large language model or knowledge prompt section. Here the large language model basically helps to refine the candidate list basically, and here knowledge prompt helps large language model to refine this list more accurately. The knowledge prompt is basically built by two example pool. One is analogy pool, another one is supplement pool. Analogy pool is basically helps LLM to guide about the relational meaning, like what is the query. Based on the query, the analogy pool will add in the prompt like more relational based information, whereas supplement pool will give the head entity or the tail entity which will be present in the input query. It will add more information about that entity, specific entity. These two pool together will help LLM to guide or to predict more accurate candidate list. After process this from this knowledge prompt and refining task, the LLM will give one top M candidate list, which is more refined candidate list, which is named as RLLM. After that, the KICGPT main output will be the more comprehensive and combined output from LLM retriever and the KGC retriever. This is comprehensive because this output, this candidate list, is benefit from both the structured retriever and the LLM based contextual retriever. Now moving on to the knowledge prompt. This is another key innovation of this research work. This knowledge prompt, they have basically applied the in-context learning for knowledge graph completion task. This in-context learning basically built by two example pool. One is analogy pool, another one is supplement pool. Analogy pool is basically gives more analogy about the relation. Like for example, like the query is, if the query is about the born in, like for example, X is born in is the relation, so the analogy pool will give more contextual information about the born in type information, so the LLM will have more contextual understanding about the born in relation. Whereas the supplement pool will help to LLM to add more information about the specific entity which will be present in the input entities. Like if the input is X, so the head entity, or it could be a tail entity, so the supplement pool will add more information about that specific entity, so the LLM will get the more information about that entity. So together this pool will help LLM to predict the candidate more accurately. Now the prompt engineering. Prompt engineering is basically is a structured format to give the input as a structured format. So there is a 4 stages, interaction stages. One is responsibility description, question and demonstration description, multiple demonstration, and final query. You can see in this prompt engineering you can see in this picture, like the authors of this paper have done these 4 stages in this way. Like in the responsibility description, they basically ask the LLM that if the LLM will do this work or not. The LLM will respond at them that the LLM can do this. Like the second stage is the question and demonstration description. Here basically the authors give the understanding what will be the task, and in the third stage, multiple demonstration, here the authors giving the analogy and supplement pool information, and the final query is this is the text of alignment. The freebase or raw relation description might look like /TV program and /country _of_origin. It might look like this. This is quite hard to understand LLM what is actually mean of that. So the authors of this paper formatted this information into a default version or TSA version. Default version is like country of origin of TV program of TV, and the TSA format is like T is the country where the TV program age originated from. Here TSA formatted is more look like natural and understandable, which might help LLM to understand more contextually. So the LLM contextually, which LLM will might help to proceed it works. This is the prompt, how they create the text self-alignment formatted of text. And the dataset, there is dataset. In this research work, authors basically used to widely used benchmark dataset for link prediction task. First one is FB15K 237, which is taken by the freebase dataset, which is a subset of freebase dataset. This is basically contain the common sense knowledge about the topics such as movies, sports, awards, traveling. Another one is WN18RR, which is for a subset of WordNet dataset. This is basically a knowledge about English morphology. Each dataset remove the inverse relation in case of information leakage. In the implementation part, in the retriever part, in the implementation, now moving on to the implementation. In the retriever part, in this research work, they have used the rotate E model, and in the re-ranker part, they have used the ChatGPT GPT 3.5 Turbo model for LLM. In this research, they basically compared their model method with triple based method, based method, and LLM based method. Triple based method, for example, Araska, Trans-E, Dismal, they basically used the structured format of the information. Information, and text-based method, they basically incorporate the description of the knowledge, and in the LLM-based method, they basically used the zero-shot and one-shot model. And in this comparison has conducted on two datasets, FB15K237 and WN18RR datasets, and in every evaluation, like MRR hit at 1, hit at 3, 10, MRR 10, everywhere KICGPT outperformed than their previous baseline method, and except one method like MIM-KGC method have outperformed in hit rate 1 in the dataset 18 WN18RR. So moving on to the evaluation study, they have done the evaluation study with shuffling the top M entities in retriever before feeding into the LLM. The second one is randomizing the demonstration orders from the analogy and supplement pools. Third one is retrieving random triples from the KG for demonstration. The fourth one is excluding all demonstration, provide the top M candidates, no prompt engineering. In this evaluation study, they have showed that every component is important, because when they are applied every components, the KICGPT outperform than all other tasks. When they have just applied the prompt engineering, they are not good at this. When they have applied all of this component, they are outperformed than all other components. So in conclusion, we can say that this is the this research work basically integrate large language model with the traditional knowledge graph completion method, which is a triple bed method for link prediction task. And then another key innovation is knowledge prompt, where they have applied the in-context learning. For that reason, they don't need any training or fine-tuning. The training-free property of large language model, they basically handle the long tail entities and the computational cost issue. Thank you.